Let's explore the fundamental principles of API design. We will focus on building robust and scalable application programming interfaces. This presentation covers three main topics: representational state transfer, or RESTful APIs, GraphQL, and API versioning. Let's dive into the fundamentals of representational state transfer. One key principle is that REST APIs are stateless. Each request from the client to the server must contain all the information needed to understand the request, without relying on any server context. Another principle is that REST APIs are resource-based. Uniform resource locators, or URLs, should represent resources, not actions. We also use HTTP methods appropriately, like GET, POST, PUT, and DELETE. Finally, REST APIs provide a uniform interface, which means consistent conventions are used across all endpoints. In representational state transfer, we use Hypertext Transfer Protocol, or HTTP methods to perform different operations on resources. The GET method is used to retrieve data from the server. For example, get/API/users. The POST method is used to create a new resource. For example, post/API/users. The PUT method is used to update an existing resource. For example, put/API/users/123. And the delete method is used to remove a resource. For example, delete/API/users/123. Let's look at an example representational state transfer API for managing users. To retrieve a list of all users, you would use get/API/users. To retrieve a specific user with an ID of 123, you would use get/API/users/123. To create a new user, you would use post/API/users. To update an existing user with an ID of 123, you would use put/API/users/123. To delete the user with an ID of 123, you would use delete/API/users/123. Here's an example JavaScript object notation, or JSON response for a user, showing the ID, name, email, and status as active. Now let's switch gears and talk about GraphQL. GraphQL is a query language for your APIs. GraphQL uses a single endpoint, which handles all requests with flexible queries. It allows you to fetch exactly the data you need, nothing more. GraphQL has a strong type system, using a schema-first approach with type safety. Finally, GraphQL offers built-in support for real-time updates using subscriptions. Here's an example of a GraphQL query and its response. The query retrieves a user with an ID of 123, including their name, email, and a list of their posts with titles and content. The response includes the requested user data, with their name, email, and an array of posts containing the title and content for each post. Let's explore different strategies for API versioning. The first strategy is to include the version number in the Uniform Resource Locator, or URL path. For example, /API/version1/users. Another strategy is to use a query parameter. For example, /API/users?version equals 1. Another approach is to use a custom HTTP header. For example, API version:\version1. And finally, you can specify the version in the accept header. For example, accept:\application/vendor. API plus JSON :version equals 1. Let's discuss some best practices for API design. It is essential to provide comprehensive documentation with examples and clear endpoints. Security is crucial, including authentication, authorization, and rate limiting. You need to track performance, errors, and usage metrics. Finally, maintain consistency in naming, error handling, and response formats. Build APIs that developers love to use. If you like this video, Hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.